Alright, so begins another draft physics video presentation. Yes. Uh, so, um, Might as well get to it. So there's this new guy I found, sort of interesting. Sort of just points out how cruel the internet is, in the sense that he makes pretty good videos. I don't agree with any of the physics, of course, but as physics instruction videos go, they're pretty high quality in terms of he's quick, he's got good animations, blah, blah, blah. But only 1.7K subscribers. I mean, I have more subscribers, which is, yes, I know. Frankly, some people would find that just totally obnoxious. I mean, I'm just saying. I'm not saying I should have less. I'm just saying he obviously should have more. Just in the sense of providing people what they want to hear, which is the silly theories in sort of, a technically accurate-ish kind of way without too much technicality, So it's a decent mix, kind of pointing out that the simple story isn't the complete story, but what they add to the story, I would argue, is garbage. But anyway, it's Adams and Sporks, so I figure we'll play some of this. It's 18 minutes. He talks fast, but so it's a lot of content in 18 minutes, frankly. But I'll just go over the basics and point out just how wrong-headed the whole thing is. And it's the irony is they sort of get that it doesn't make much sense what they say, and so they should say it differently. But the different they add doesn't fix it. It's still fundamentally broken, and that's the real argument, is that none of the physicists really want to discuss, when they talk about fundamental physics, they think fundamental physics is entanglement or something, or why are we conscious, or some sort of, completely unrelated question. Anyway, completely unrelated to fundamental physics.
Changing electric fields don't cause magnetic fields, and just as importantly, changing magnetic fields don't cause electric fields. Hi everyone, welcome to Adams and Sporks.
So fields don't cause fields. Well, that's sort of, you'd sort of argue like, okay, they got this idea of a virtual photon as the communicator between electrons and protons. And they ought to just stick with that idea, that they have a thing. They understand that it's a thing, it transmits back and forth, it communicates. And they ought to just realize that this wave mush doesn't say anything. It's the emergent property, not the fundamental property. But anyway.
Sporks, and today I want to talk about some misconceptions I hear about electromagnetic radiation and light. And actually, I want to tell you about how the entirety of the physics of electromagnetism is more straightforward than a lot of people seem to think. Let me start by sort of laying out a way of thinking about electromagnetism and light.
Straightforward is not what you're going to get to. Because again, you're just, as soon as you start talking about fields of nothing, okay, and that you somehow have a field that's doing something, you've abstracted what the real trick is, which is there's this energy stuff. There's a real stuff that's in between all of this stuff. And that stuff is affected by movement. If you're moving through the stuff, you're going to change how the stuff behaves, because you're moving through it.
But I'm going to say, isn't that great? Now, not everything I'm about to say is wrong, although some of it is, but it's making things a lot more clunky and complicated than they need to be. So let's lay out these ideas I want to attack. The idea is that electromagnetism...
So that's all I want to do. I just want to attack these ideas. Why don't you just start with the idea that first there is no electromagnetism, that they're different phenomenons. Electricity is strictly a thing that happens between charges, and the fact is they put atoms between two charges, that is, atoms between a potential difference, that the atoms will transmit the potential difference. There really is no such thing as electricity. Electricity is just the phenomenon of moving, the pressure, the force, the virtual photons from one place to another place.
It's basically all about three fundamental objects. You have your electric charges.
There you go. And your magnetic charges. They're neither electric or magnetic. They're charges. Okay, and the phenomenon of charge is the phenomenon that's creating both magnetism and electricity. Okay, but the two things are one is something. They're both things atoms do. Okay, so let's just start there. All right, so let's add a little value. I guess I could just do that. Create a little more room. That's good enough, I think. All right. So yes, you have these two charges, and they're distinctly different things. You could argue, you know, make them a different shape for the sake of the argument. And what you know about them is they behave inversely. That is, I could be creating a virtual field of virtual photons, right? A magnetic field or an electric field. And the point is those fields have two distinctly different properties in the sense that if I can identify them as different. So I could say that the field, if I was just thinking about the field as being a smaller version of the big thing, all right, that the field could be little triangles or the field could be little circles. And the two things act inversely to those opposite fields. So if I hit it with the little triangle field, it'll end up moving towards. If I hit it with the little if I hit a triangle with a little circle field, it moves towards. And then if I do the opposite triangle on triangle, you know, if I have a triangle field that is something triangular, that's creating a triangle field, it will be repulsive. All right, and the same goes for the circle thing. So those are the basic rules you know. You know that the two things create an opposite field, all right, that this one somehow is radiating something opposite to what this is radiating. Okay, whatever this is radiating the opposite version of it. In terms of the reaction will be the opposite. The triangle things will attract to the squiggly field, and they will they'll reflect the straight line field. And those are the two fields. The fields are the two elemental charges, and the fact that the mediator between those charges can simply be understood, all right, as a form of radiation. That this one radiates, let's call this the proton radiation, and this one radiates electron radiation. And then if I hit a proton with an electron radiation, it doesn't move away. It moves some other direction. And if I hit an electron with proton radiation, with electron radiation, you know, it will move away. And if I hit it with proton radiation, it won't move away. It'll move towards. And those are the tendencies. And that's the way to understand the fields. The fields have to be made of something. And we know the something they're made of is moving the speed of light. And we know it's quantum mechanics, that it comes in quantum pieces, chunks, bits, little tiny bits of momentum. So there's no point in talking about these fields as if they're an abstraction or a virtual thing. They're an actual thing that these things radiate, because this one reflects, okay, triangles. A triangle hits it, it reflects it back to the other guy, and the other guy says, I don't like triangles either, so he reflects it back, and they end up pushing it back and forth, and like a ping pong ball trapped between two paddles. As you bring them closer, you double the amount of pressure between them. And it's that simple. That's what charge is doing. All right.
Create electric fields. You have your electric currents, which create magnetic fields. And finally, there's a third, very special object called an electromagnetic wave, or electromagnetic radiation, which is kind of its own independent thing. These waves are often...
Independent thing. It's completely not an independent thing. It's completely an electron thing. All right, so, you know, I could do both parts, he said there. You know, first, there's the fields are real, but the point really is that when he says wave, all this is saying is that if this thing was, if you did have a charge, and if you accept the argument that this charge is constantly reflecting the whatever comes into it, okay, in terms of triangles anyway, or circles in this case, but whatever, the energy that is the same as it is, right, and it reflects that back to the world. All right, so if you first understand, that's all it's doing. It's getting hit from the universe by a whole bunch of these little bits, and it reflects perfectly all of the ones that are the electron force. So in this case, we'll just use circles. And if they're triangles, something different happens where the triangle ends up coming out perpendicularly. So the reflection isn't perfect. So triangles can't get trapped. Anyway, so what do I want to say? Okay, so the simple argument, look, if this electron is sitting someplace and it's radiating, you can understand that if it moves its position, so it's radiating, that is, it's reflecting, and there's a certain density to the energy that it reflects. Now, if I move it from this position to this position fairly fast, okay, might be able to understand that during the process of moving, it's going to take all the stuff that hits it in this position, this position, this position, and spread it, okay, essentially over distance, and so it's going to be in the direction it's moving, it's going to hit more stuff, so it's going to create a thicker density. All right, that means that it's going to reflect when it finally reaches this point. You could argue that for a period of time, there's going to be a thick amount of energy in that it's reflecting, right? And if in the opposite direction, that is the direction away from where it's moving, you can understand that now less force is going to hit it because it moved, in the same direction as the force, so the reflections happen much later, and so that this is going to be much less dense. On this side, it's going to seem like there's less stuff being reflected, and so that's the essence of the wave. The wave is just, if I move, the wave goes from being, it goes from being just a solid amount of reflections happening, in a period of time. There's that many reflections, and instead it becomes, a little bit more in this chunk of time. Make that darker. All right, more in this chunk of time than this chunk of time. So you end up with what you could call a wave, right? Because there'll be a little bit more here. If this thing's moving back and forth, you can understand that it creates a consolidation of pressure of the number of reflections at this point in time, and in this point in time, and at another point in time. That would go on and on. I guess I can afford to put one more in there. All right. And those are your waves. But your waves are made out of something real hitting it. All right. So this wave is really discrete bits doing discrete things. It's not a wave held together. It's not in tension. It's not in any of that stuff. It just happens that if you move the object to a new position, the process of moving in the forward direction creates more density of interactions, and in the backward condition it creates less density. Probably need to make this very bright, so you end up with more density forward and less density backward, and that's all a wave is it's just a signal that has changes in the density. That's essentially your wave. I mean, that's the first thing to understand, is that a wave is emergent, and a wave is just a density change. A volume change, a pressure change.
Illustrated with a diagram like this. What this is basically showing is that if I stood at a certain spot as one of these waves passing by, that I would detect an electric field whose direction was oscillating up to down, up to down, up to down, up to down, and I would detect a magnetic field whose direction is oscillating left to right, left to right, left to right.
All right, so let's understand the changes in these fields, the directions of these fields. They really don't have all that much directionality, except for if you understand when you're when you're changing an atom, when you have an atom. See, they have this view that this electron is spinning around and it's creating some sort of, the only time it has a position is at a point in time, and you say this is its magnetic moment at a certain position. But if you understood the atom as really rigid things, the proton's in semi-rigid position, the electron's in a semi-rigid position, it's not going anywhere, it's not moving all over the place. It's in a position, and you can knock it in and out of that position. That is, you can hit it and cause it to move, and then it'll rebound, go back to its position, and then you can hit it and cause it to move, and then it'll rebound back to its position. And again, that's creating the wave. That's creating the higher density and force in one direction than in the other direction it's moving. All right. So that's easy to understand. And so the polarity, or what direction it's doing something. So if you're pushing electricity through a conductor, for example, the idea is that these electrons are all in tension with each other. They're all signaling with virtual photons back and forth, back and forth. And they're in tension with each other. They're tied to each other when they're atoms, in atoms. And all you're really doing is moving one electron, which moves the other electron, which moves the other electron, and increases the pressure between them precipitatively in a direction. So that's a flow of electricity. That's why it has a direction. Now the fact that that movement, moving that electron, changes the profile of the proton to the electron, which means now that's just a dipole argument. So if I change where this electron is positioned, that is how close it is to this proton, you can sort of understand if I put the electron out here, it has a different profile, and that this electron, even if it was light, and you had your eye was over here, and you were going to look at this, the closer I bring the electron, the less of the proton you can see, right? So you won't see the proton, but the closer I bring the electron to the surface of the proton, the bigger the proton gets. In the sense, the more I can see the proton. And that's the magnetic field that's created. And the field is created in a direction that's perpendicular to the electric field. That is, if you're pushing electrons this way, you're creating magnetism this way, in the sense that you're polarizing the atoms in this direction. Like this would be the more north end and this would be the south end. So you're aligning the magnets. Okay, by pushing electricity, you're aligning the magnets. That's that simple. An explanation is all you need to understand that that's the magnetism being created, because you're lining up all these atoms, which means this atom has probably got its electron here and its proton over here. They're all kind of staggered to create even tension. So when you tilt one, you tilt this one, you start tilting them all, then you end up creating a big giant magnet. You add up a lot of little magnets, you end up with a big magnet. And that's all. And the magnet just means is that one end is excreting. Okay, they're doing the same thing the charges would do. So if you just think of the south end of the magnet as the proton end, and the north end is the electron end, okay, you're done. It's then you know this is repelling electrons, and this end is repelling protons, and inversely attracting, and then that's going to have an effect on stuff out here. And that the more of these little atoms you line up in the same direction, the stronger the magnetic effect, and the stronger the influence will be. That if you're pushing, triangles in here, they'll come out this end, and if you push circles in here, they'll come out this end. So you're magnifying the segregation, the splitting of the two kinds of virtual photon, and by segregating the force, you make the force more powerful. And it becomes all repulsive or all attractive, instead of being a mixture of the two, which is nothing. If I create a low pressure and a high pressure that are of equal amounts, they balance out and become nothing. So, but if I can push all the low pressures this way and all the high pressures that way, then they add.
And if I single out one of these maxima to stock, because, hey, everyone needs a hobby, I'd find that this maxima, this peak, travels at the speed of light. And then that's one of the big reveals of electromagnetism. It's not a coincidence that this electromagnetic radiation travels at the speed of light.
Again, so he's calling it radiation, electromagnetic radiation, but again, you don't think it's radiation in the sense you don't think it's a hydrogen nucleus or a helium nucleus, or you don't think of it as an electron even. You're thinking of it as some sort of field thing, whatever that would be, whatever a field thing would be. And you won't say, well, it's made out of like ether particles, or it's made out of balloons, or it's made out of something. You don't give any form or structure to this at all, which is just kind of nonsense. It's real stuff, it's real energy, and all you're doing with these silly wave things is measuring the density of the energy. You're just saying, is there a lot of particles in this little area of space? Are there less particles here? Are there more particles here? Are there less particles here? Particle in terms of bits of quanta that define a photon. A photon is defined by having a regular sequence of high pressure hit an electron. A certain number of nodes, okay, of a higher density of substance.
Is light. That's what light is. It's one of these sinusoidal electromagnetic waves.
Again, it's one of these. No, it really isn't. That's not what it visually, that's not what it looks like. That's not what it is. Unless you understand that those little vector lines mean a quantity of something. Then it might have some hope of representing the truth. But it certainly doesn't have any up and down. There's no opposite. There's no plus a ton, minus a ton. So it can't be understood in that way. And you can sort of understand it that if you break this down in these two fields, you could understand that that's the triangles and the squares. The ones going up are the triangles, the ones the squares are going the other way. But that's not what their math is doing. They're recognizing that you need two things to make the system work, but they have the two things misidentified. They don't have an electron component of the photon and a proton component. Because it wouldn't be a proton component, frankly, because you're just moving electrons. So it's all, if electrons are triangles, it's all triangle force that electromagnetic radiation is made out of.
But in fact, it's often said that these electromagnetic waves aren't just independent, but the reason they exist is because they're also self-creating. As the story goes, electric and magnetic fields interact with each other. Specifically, if I have, at a spot, a changing electric field, that changing field then creates a magnetic field.
Right, and none of this makes any sense because these field changes, if you measure the polarization of the light, for example, are huge. Thousands of atoms worth of field change. The field change is taking place over a width of thousands of atoms. And clearly, it's not incoherent to say within all those thousands of atoms, only one electron is going to be wobbled by the field change. It's completely incoherent as an explanation. It doesn't make sense.
Changing electric fields create magnetic fields. On the flip side, if I have a changing magnetic field, that then creates an electric field. So it's said that these perfect little sinusoidal
Now, so the only thing you have to understand is the word change in the sense that movement causes movement. And if all you have is the field and it's static, everything already balanced to it. The universe is running at the clock speed of the speed of light, the speed of the force. So any change you make at the speed of light, okay, that change is communicated to the rest of the universe. And clearly the universe for small things is a very small universe they're living in. And so the information gets around very fast and everything readjusts to the position. And so unless you keep moving the thing that's creating the field, that is the thing reflecting the universe to you, yes, there's no change. Nothing will happen. Nothing else moves. So you just have to think of these things as being, the simple, I gave the analogy of like force fields on the Enterprise or something. But yes, you have to think about the electron and the proton as being objects that have a force field, that have a range of influence that's, where the influence is significant. And it's at the R squared rule or whatever. And so it diminishes quickly. But there's this realm where their fields interact with the world. And so when two electrons meet each other, they have this field. And when this object's field changes the surface here by adding or subtracting to what this usually feels, or vice versa, this field reaches this surface, the reflections change. That is, it goes from reflecting energy at this kind of rate to reflecting energy at this kind of rate. And more interactions equals more energy. The things don't have to move faster. Nothing has to change. All you've done is change the distance, which incidentally changes the energy in the sense that it increases the interactions, and the interactions are what causes the motion. I mean, right now you're radiating light. And you could sort of probably understand that you're probably reflecting a lot of other kinds of radiation that's hitting you and bouncing off of you. And then there's radiation that's going inside of you, to some extent heating you a little bit and then re-radiating as infrared radiation. So you're radiating a field. And the point isn't that you don't have a field when you're sitting still. The point is for your field to affect matter, it has to push into the universe. It has to move to change the field pressure in the rest of the universe. I have to move me, you have to change the field pressure around me. When two fingers collide, it's the pressure between the electrons that is colliding. It isn't the actual electrons. It isn't the actual matter. That's not hitting each other. They're just feeling each other's field, increasing the pressure. The little ball bouncing between them starts bouncing incredibly fast, creating a lot of reason to move apart.
Objects propagate out forever across the cosmos because they're basically the perfect exploit to these interactions. They're a cheat code, if you will, to this way that electric and magnetic fields interact with each other and create and reinforce themselves. And end misconception. So what I want to do today is maybe sort of tear down a lot of these ideas, but maybe just to quickly summarize.
So again, it's not really going to do any tearing down, because they ought to just start with Maxwell's original drawings of charge. Just start there, and don't be fooled by Faraday's this description of a line of force. I mean, Maxwell's drawings of charges, okay, is clearly this. It's radiating from all directions just like a sun. These lines, these are the lines of force. All right? And they diminish with distance by the inverse square law, and you can just see that kind of logically. They're spreading in both directions, and so they're losing, they're being diluted by being spread over a greater amount of space. But these are the only lines, these dead straight lines. These are the lines of force. And yes, I could draw a circle here and say all of these points have the same pressure out, because there'll be the same density of particles hitting each one of these areas at any particular time. So I can draw another kind of line, but this line doesn't exist. Nothing's moving on this line. There's no arrows on this line. It's not doing anything. This, perpendicular to that line, is the direction that some charge will leave in. This is the real force, is a force radiating out. And the only key to understanding this is understanding that this force that this one's radiating is inverse to the force that this other thing is radiating. It's also radiating a force out. See, Maxwell drew it as a force in, but it doesn't really matter because it just depends on what test charge you're using. In is the same as out. The same rules apply. And he's just trying to figure out a way of describing the fact that they have an inverse property. But the problem was they did this kind of nonsense. You know, they start it here and have it terminate somewhere else. And yeah, that's what a charge will do when it's put in the field. But that's not what the field is doing. Both objects are radiating opposite force. This one radiating a force that'll go out perpendicular. This one radiating a force that'll go out perpendicular from this other object. And that's the real difference. One force communicates directly back and forth. One force can be reflected. Okay, electron to electron, it can reflect the force. Electron to proton, there's no reflections because the proton force perpendicularly leaves and has lost information. This doesn't get the information back. It doesn't get the signal back. It doesn't get the radar back. The radar disappears. This one sends out its radar disappears.
As the ideas I'm kind of going after. 1. Electric fields are caused by electric charges. Magnetic fields are caused by electric currents. 2.
Wrong.
Electric and magnetic fields...
Wrong, right? I mean, magnetic fields are caused by magnets. And the only thing to argue about is what's the smallest magnet, and the smallest magnet is an atom. So what are the magnetic monopoles? Electrons and protons, the same things that are your charge monopoles, your electric monopoles, are your magnetic monopoles. What is a magnet doing? A magnet is just a filter. All right, so the filter says triangle, round, triangle, round, triangle, round, right? And this is the triangle end, the south end, the north end here, let's just say. The force comes in mixed. And what does the filter do? Well, by the rules of the right-hand rules, okay, the circles that hit the triangle end up being diverted out of the circle end, and the triangles hitting the circle end up coming out the triangle end. And so you have the triangles are all reflecting, right? And you have all the triangles that went in here are also coming out this end. So this end becomes all triangles. And this end is all circles. A magnet is just a filter. It doesn't make any new energy. It just takes what comes in and filters it. Forces the proton energy to come out of one end, forces the electron energy to come out the other end. That's all it's doing. And the smallest magnet is just the atom itself. The atom itself is doing exactly the same thing. And if you line them up, they will keep feeding the system. They will keep pushing the positive, the triangles up this way, and they'll keep pushing the, well, no, the other way around, the circles this way, and they'll keep pushing, as you line up all these magnets, they'll keep pushing triangles this way. That's the magnet. There's magnetism is just charge. That's all it is. And it's just that it's being produced. The field of charge is being magnified by the magnet.
Created by these sources then interacts with each other. 3. There is a perfect solution to these interactions, a very special field arrangement that has the very special property of reinforcing and creating itself. 4. These factory assembled fields.
So those, you should have spent more time on that kind of stuff, because that doesn't make any sense. Frankly, there's no way to create new energy. All you're doing is reflecting the world differently. The magnet's a filter, so it's just like me if I was hit with red and blue light, purple light, and you just make a rule. Okay, the blue portion reflects off the top of my body, the red portion reflects off the bottom. Now I'm already started to filter it. Then add an extra component to the filter that says, well, any of the blue stuff comes out the bottom, goes down to my legs, and any of the red stuff that hits the red stuff that hits my legs comes up the blue end, or the blue end hits my legs, it comes out the other end. So you got two ways to magnify and create segregation of the two forces. So that's all magnets are doing. They're just taking what comes in and they're giving you a different image of it back out. Just like if I was a filter and the light, I only depended on the light coming in, and I just filter it by absorbing one color and converting it and having it come out another direction, and likewise to the other half. And that's it. There's no energy needed because the energy is already in the environment.
Fields, these cheat codes in the way fields interact, are called electromagnetic radiation or light, and they travel the universe in this beautiful, elegant, sinusoidal.
So this is just more nonsense. Elegant sinusoidal. There's no need for any sinusoidal wave. There's no indication of a wave. That's what quantum mechanics is certainly telling you, is that there's no this much of a photon or this much of a photon or this much of a photon. There's only this many photons or this many photons or this many photons. The photons themselves are quantized and made out of exactly the same thing with no irregularities whatsoever except the frequency. The bullets are all the same, the gun is all the same speed, same muzzle velocity, same everything, and all you're doing is changing how fast you're pulling the trigger, and that's it. No sinusoidal. There's no sinusoidal wave to a wave of bullets. Unless you want to play some nonsense game, it just isn't there. And there's no evidence that waves do it any more sinusoidally. And then the word elegant is just silly, of course. Oh, it's beautiful, beautiful. Another insanely silly word for physicists to be using. It's beautiful. Oh, special. Why don't you just put special in there?
Electromagnetic wave shake. Now, before we set things straight, let me just point out some immediate issues with these ideas that you might realize.
So again, he says, before we set things straight, and he has this another imperfect theory. He concedes, yeah, maybe what I'm saying is right, maybe it's not. But they always talk it as if, they're really on. They got it. They're just inches away from the right answer. And, it's nowhere close because they still haven't gotten to the fundamental problem. The foundation of your building is like this, okay? It's on a 45-degree angle. Your building isn't going to work. You can keep trying to stack things up and pretend it's okay to build on a frickin' horizontal plane, but it's not rational. You have to cut a foundation, a real solid one, and you don't have that. You have mush as a foundation, wave-particle duality mush.
Let's call these sand traps.
Virtual
Even if
photon
these ideas aren't
mush.
a correct reflection of our reality, are they at least internally consistent? First of all, if I look at one of these sinusoidal electromagnetic waves, what I see is an electric field and a magnetic field kind of moving in step with each other. But hold on, that's an issue. Because if one of these is causing the other, then we'd expect some sort of, time delay. We'd expect, say...
Well, I don't think the argument is they're causing each other when they're in the form of a photon. The mechanisms that caused the photon, created the photon. See, this is the whole problem with your theory, is that you think these things are created, that photons are a creation, when no, they're just an arrangement. They're taking something that already exists and just arranging it. The bullets already exist. All you're doing is changing the timing of their flight through space.
The electric field to change first, and then that change to cause some change in the magnetic field. But that's not what we see. They're changing perfectly in step with each other, which is definitely...
All right, so when they say that's not what we see, they have no experiment seeing any of this. So again, there's no magnetic experiment with photons or electric experiment with photons that makes you see them. They don't get moved by magnetic fields, which is a huge giveaway. That you can't be right with this nonsense. It can't be a change in the density in the field. If a magnetic field, it doesn't move in a magnetic field, that doesn't make any sense. So it should be a huge giveaway that calling the photon electromagnetic is just misnomer all over the place. Wrong start.
If our misconception is right. So, suspicious note number one. If changing electric fields cause magnetic fields and vice versa, why are electric and magnetic fields and electromagnetic waves in perfect step with one another? Secondly, if I take two beams of light, say from a laser or from a flashlight, and I do what the Ghostbusters tell you never to do and cross the streams, sure, at the point of crossing, I might see something crazy like an interference pattern.
No, you won't. So you can say that, but you won't unless those are already broken beams. That is, unless you put those beams through a diffraction gradient or a polarizing filter, which means that you didn't destructively destroy any. You just damaged them a little bit. You took a little bit off the photon. So the photon was this, everything in a nice order, and all you did was, okay, they're a little bit, in reality, their polarization is telling you that they're a little bit out of alignment. All right, and so what happened was, this filter went through the 2x, thickness, and this one went through these three went through the 1x thickness, which means this one got, jumped to here in terms of its timing position. And so all you did is knock it out of timing. And now this distance wavelength is way too big. Okay, so you're not going to see this as a photon, but you're not going to get the 6 or 7 clumps of photon you need, the 6 or 7 bips in the frequency that you need to be able to say, I see it. Okay, you're not going to see it when it's in this form. And so what you can do is put it through another filter that jumps this, jumps something else, another photon's bit back into this position. Or actually corrects these 3 that are out by putting them through the 2x filter this time. These 3 go through the 2x filter. That means this is back where it belongs. And you have a photon again. But there is no destructive interference or constructive interference. You either make the photons after you broke them, you remake them out of the pieces, or you don't make a photon out of the pieces. So that's all there is. Simple explanation. But this doesn't. No point in saying that 2 beams of light could in some way interfere, because if there are 2 beams that aren't full of broken photons, they won't interfere. If you don't have any broken pieces, you won't reconstruct anything. And you certainly won't reconstruct or change their path. You won't make light from one path go down the path of the other beam. That's not going to happen, so you'd never see it even if you did it this way. If you shot two beams this way, you would see no interference pattern, even if you had broken photons. So this image is again misleading.
Or something like this. But after that, the beams continue totally unchanged, totally unaffected. The electromagnetic waves clearly aren't changed by crossing each other. This is why I can't build a lightsaber, no matter how much my 10-year-olds, or let's be honest, 30-year-old...
Right. So again, you're just arguing that, look, there's something very wrong with this theory. Your fundamental theory has some very wrong elements in the sense that these are real pressure changes in a real field. There's a ton of photons going through the same space. You know that. A ton of them. You can increase the number to huge numbers of photons that are traveling through a given piece of space. And they're all huge in terms of their polarization. Okay, thousands of atoms worth of distance between their constituent bits. And they're all swirling, mixing together. And if they were really changes in an actual field, how could the field not add them up? How could the field not push more in one direction and push, it couldn't have you couldn't make the field to reflect the discreteness of each of those bits. The discreteness would get lost in the movement of whatever this field is.
Itself wants one. If electromagnetic fields allegedly affect and cause one another, it seems awfully strange that two light beams can pass through one another without them having any effect on one another. So suspicious notion number 2, if electric and magnetic fields interact, why don't electromagnetic waves interact? Thirdly, isn't it weird to say that currents create magnetic fields?
It's just weird to say the word field when you aren't making it out of anything. And again, you're supposed to kind of be subtly saying, oh no, well, we know our field is something. It's a virtual photon. So why don't you just stick with that concept and then explain why don't the virtual photons interfere with each other? And that argument can be made where you just say, well, because they don't. Because the only thing they react to is when they hit matter. The only way the field, the force, can have any meaning is it has to have a matter bit to hit. If it doesn't hit a matter bit, it can't do anything. All right? And likewise, the matter can't do anything until a force hits it, till the external world applies a pressure to it. It has no motor. It can't just, flip a switch and go. It has to be forced to go.
I mean, electric charges are like fundamental things in our universe. You have electrons, you have protons, you have muons, and...
No, you don't need any of those other things. No, you really don't. You have electrons and protons, and when you put two electron really close to a proton, you got a neutron. There, you're done. You don't need to do any more dissection. You've got all the important parts of the atom body. You don't need quarks. You don't need neutrinos. You don't need any of these, bizarre things that don't exist in reality in any sense, and they're just things that science decided to call something because something was being pushed by a force, right? I mean, all these particles are made because they say an electron is moving too fast or a proton is moving too fast. That's all they're created out of. And so the simple explanation for that is that once you have an electron going fairly fast and say that was a ray of energy, okay, that is the cause of its motion, and that ray has a lot of nodes to it, you could understand that once it's approaching half the speed of light or 3/4 of the speed of light, that it's going to take a while for all of these nodes of energy to get through, to push and hit, push and hit, push and hit. So if this thing's moving 3/4 of the speed of these things, it's going to take quite a while for all of that energy to work its way through the object, and then the object can be killed by drag. Then drag can slow it down because it's going to hit more force going forward than coming from the back. But as long as it's still being pushed, it's going to keep accelerating, and then once it uses up its pushing force, then it's going to decelerate. But it really just has to do with how much energy, how long a ray, the ray length will decide how fast this thing ends up going. And so they just say, well, if it's going a certain speed, then it's a neutrino. If it's another speed, it's some other anti-thingy, or it's some other kind of bullshit. Sorry for my, But it's not a real particle. It's just charge again. Charge. It's just charge. There's just electrons and protons, and that's all there really is. That's the nature. This is the fundamental element of the universe, is this function, and the fact that there's two kinds of force that are likewise positive and negative, in the sense that they have inverse relationship to each other. I mean, I could go with the simple pure reflection versus this. Okay, so when proton force hits an electron, it does this thing. When an electron force hits an electron hits an electron, it does this perfect reflection thing.
Go on. But electric wires and electrical currents are just like a human technology. In fact, electric currents are really just a rebranding of electrical charges in a specific scenario. To see that this is the case, imagine two...
So again, he's making the reasonable argument, but he's going to make it in the context of the broken foundation. So he's saying the building's crooked, but he's not going to fix the foundation. He's just going to try to build a straight building on top of the crooked foundation again. He's going to take another shot at that. And I would argue that's doomed to fail. But it is important to recognize that electricity is just an atomic phenomenon. It's kind of chemistry, all right? Theoretically, electricity is chemistry. It really isn't physics, really, because you need atoms to do it.
Infinite lines of charge, one line of positive charge and one line of negative charge, sitting on top of each other. Now, if either of these charges were by themselves, they'd surround themselves with an electric field, because charges create electric fields. But because at every point along our line there are equal numbers of positive and negative charges...
Okay, so again, they don't create a field, they just reflect the energy that hits them. And again, they're reflecting it with a little trick. And the little trick is if the opposite energy comes in, it takes a right turn. And the motion is sideways. And if the right energy hits the same energy, then it's a reflection. The momentum goes into the object, and it gives back to the universe some energy going the opposite direction.
The net charge is zero, and therefore the electric field is zero. Of course, in this case, where both lines are stationary, there's no magnetic field either. This is basically the case of a neutral wire if there's no current.
So again, a magnetic field is just a segregated field. It's just the regular pressure of the universe, red and blue, triangle, square, segregated. So now everything triangular that hit the object is coming out one side, everything square is coming out the other. Circular, however.
Current, all I need to do is then start moving one of these line charges at a constant speed. So really the idea of electrical currents is just sort of a cockamamie scheme to create a scenario where I have charges that are moving, but no actual net charges. So even though there are charges there, they're cancelled, so it's a purely magnetic situation because of that. This can be made pretty clear if I just show you the magnetic field around a single moving charge. So you see a single charge moving with...
So again, he says he's seen this thing. He hasn't seen this magnetic field around a moving charge. The only thing that can be magnetic is a dipole. That is the atom. You can make it magnetic. When you separate the smallest magnet, the atom, into electrons and protons, you just have charge. There's no magnetic field. There's a charge field. Now maybe that's all you should talk about, is a charge field. And there's the dipole field versus the monopole field. The monopole field being electricity, the dipole field being magnets. But there's only one field. It has two constituents, triangles and squares, or triangles and circles.
The constant speed sort of just dresses itself with a magnetic field as it moves. So suspicious notion number 3, forget about currents. Electric and magnetic fields don't really come from different places.
So let's understand. The simple argument is you've not changed anything, okay, in the nature of the charge. The charge is a charge is a charge is a charge. All you're doing is making more of the atoms into filters. So if you have a bunch of atoms all pointing, having an electron and proton in different directions, so we just have that as a, north-south, you can get it. All right, so you just have them lined up in different ways. The material isn't going to filter all the north energy and the electron and the proton force, it's not going to segregate any of it, right? But if the more of these I line up the same way, then they will collectively add a bias and start making it filter. And so now purple will go in, and a little more red goes out this end, and a little more blue goes out this end. And the more of these things I line up, then the more purple the more blue down here, the more red up here, the more segregated the mixed force becomes. The magnet is just a consequence. So when you shoot electricity through the wire, you start polarizing the atoms. That is, you're forcing the atoms to line up because the pressure is going through the electrons, which is causing the electrons to line up. Once the electrons line up, the protons have to follow, which means you create a bunch of little magnets, and the little magnets make a big magnet.
In reality, any old charge which is moving has both an electric and magnetic field around it, just like an electromagnetic wave. So what's special about electromagnetic waves? So okay, then we've identified the fair amount of dubiousness around these ideas, but then how does it work?
So electromagnetic virtual photons, right? That's what you should be saying, something stupid like that, right? It's not, again, it's I've already said it. There's one field of one kind of thing moving the speed of light, and all you're doing is saying, yes, just like there's two parts to the atom, there's two parts to the field. And it's just about segregating those two or sending those two in a frequency, that is, having a high density in a specific amount of space of triangles, and then a high density of triangles and a high density of triangles. That's the photon.
Well, let's say I have an electric charge just moving on some crazy trajectory through space. We don't care why it's moving that way or how it's moving that way. All we want to know is that at any given moment, what is the electric and magnetic field I will detect at some arbitrary point?
Well, it's really important to understand why it's not moving regularly, right? So you just kind of, who cares? Well, no, that's kind of fundamental, because that's all a force that's causing that. Nothing changes spontaneously, or it always requires a mechanism, and with something as elemental as an electron, the mechanism has to be elemental. It really has to be the force. There's no like clock inside of the electron that's ticking and saying, oh, in 4 seconds I'm going to go left because something's going to tick and click and go bing and I go left. No, if it does something, it's doing it because the universe told it so. Okay, the universe tells the electron what to do. All right, so if it moves sideways, or it goes this way, or goes that way, it's going to do it because the forces affecting it at that position changed. It got acted on by a force and was forced to change its position because something hit it, okay, and it made exchanges in momentum with it, and those exchanges meant it has a course. So the idea would be is that it gets hit by it's pushed, so initial momentum has to be created by it getting hit by some triangles, and then it gets hit by a few circles, and the circles end up creating motion in the perpendicular direction, so now it moves a little this way, and then it gets hit by some triangles from this way, and so then it goes this way. But every bit of it is for a reason. There's no free movement. Every bit of its course is dictated by the pressure it's moving in.
Point. Let's call that point A. If you can figure that out, you've essentially figured out all the physics of electromagnetism. That may seem like an exaggeration, but really it's not. And that's because, as we'll see, electromagnetic fields don't interact at all, unlike our misconception. This means that the electromagnetic field due to a...
So let's just understand, photons don't interact. And so this is the what's the word? A superposition argument, right? Where superposition originally meant that everything has its own its own field that it's creating, like a gravity. Everything has its own thing. And if I put 4 things into a field and the different charges or whatever, these fields don't interact with each other and mix, and then create some field in here that's some other different kind of field. they don't mix in the sense of they don't create the field doesn't affect the field and then create a new field. Each one throws their peanut butter in, and the other one throws its jelly in, and this one throws its sardines in, and that's what you really have. Okay, so you have real sardines, and you have real peanut butter, and you have real jelly, but it never turns into a sandwich, or it's never mixed in a blender or any of that stuff. And so the actual sardine has to hit this guy. An actual sardine has to hit this guy. And this guy's peanut butter has to actually hit this guy. And this guy's, whatever the other thing, jelly has to actually hit this guy. There's no getting around it. The fields actually hit material things. And the material things say, how many sardines did I get hit by? How many sardines? Right? How many peanut butter blobs? And how much jelly did I get hit with? And then the thing makes the sandwich. The sandwich will be a net effect on its motion, a net effect on its momentum. But it really has to be hit by the stuff. These things are all independent agents with independent fields. And the fields have to reach the matter. They have to go there. These are real little things communicated. Real little things thrown back and forth. Real little things thrown back and forth. And at the speed of light.
A large, complicated object made of billions of particles is really just the sum of the individual fields of each particle. So if you know it for one particle, you know it for a billion particles. So with that in mind, all of electromagnetism can just be summed up like this. The electromagnetic field detected at a given point in space is just the time-delayed effect of the position, velocity, and acceleration of a charge at an...
Right. So he says it's the effect of those things, but the position, obviously, you can have no velocity and you can have no acceleration. So you can be sending nothing but your reflection to the world. I'm sitting in one position, I'm reflecting light. If you're in a certain position, it becomes a static thing. You're getting hit with a certain amount of light reflecting off of me, period. That's it. Now, if I move, all right, then I'm in a new position. And besides the fact that I'm moving into a field, which means I'm going to multiply the fact that I'm going to hit more stuff because I'm moving into the stuff. So now I've increased the density of the field you're going to get hit by while I'm moving. I'm increasing the density because I'm moving into some matter, some force, and I'm moving away from other force in the back. So behind me, there's a decrease in density because the reflections can't happen as when they were supposed to. They're going to happen later than they're supposed to. And that later will be revealed in a portion of space that's going to be less. There's going to be less stuff in it, less peanut butter. So if I'm secreting peanut butter, right, well, I'm going to reflect peanut butter. And so if the field is throwing peanut butter at me and I'm reflecting it perfectly, you can just sort of get the idea. If I'm moving in to the peanut butter, right, okay, there's going to be a higher density of peanut butter hitting you. And if I'm moving away, the peanut butter is trying to hit me from the back, but I'm moving, then that back there is going to get a little period where it's not going to have equilibrium, where there's going to be less peanut butter. I'm reflecting at it because I'm moving away from the motion, its motion. I'm increasing its distance it has to travel, and that increase in distance will result in one of those little black lines in a little space where, it's destructive interference. I'm not getting any peanut butter.
earlier time. That's a bit wordy, but let me show you what I mean. And so the way of thinking about this is that a charge is like a beacon, and at every moment it is broadcasting in all directions.
Yay! Alright, but it's not beaconing. It's not going blip, 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 blip. There's no frequency if it's not moving. Alright, then there's just reflecting the world. And yeah, the world can already have frequencies in it, and I'll just reflect them back to you. And that's what the electron is doing. It'll just reflect back whatever you throw at it. Okay, in the triangle sense. Now, circles, it's going to send them going the wrong way. But it's also going to send them as a frequency. What comes in is going to go out at the same frequency that way. So I'll reflect whatever you throw at me. So if you throw blips at me, I'll blip. But I don't have to do any of this blippy stuff. I'm just reflecting whatever hits me. And now if you move me, then you change the reflection.
Two pieces of information: its current velocity and how that current velocity is changing, in other words, its acceleration. And at every moment, moment to moment, that's all it does. However, these broad...
So again, you can understand that with the better analogy, which is the ping pong ball analogy, right? I got two paddles and a ball that never loses energy and always travels the same speed. And you can just see it right now, right, going right back and forth between my hands, right? And you can just get that if I move my hands closer together, the ball goes crazy. And each one of those interactions is an exchange with this paddle, saying, go that way, go that way, go that way, go that way. Each one of them. So if I increase the number of times it hits, I increase the amount of energy pushing it, an amount of force pushing it. And if I expand it, I do likewise. But that's how to really visualize this, is that between each electron, there's this stuff communicating back and forth at the speed of light. And yes, you can give it a frequency. Yes, you can have a higher density moving. You can have four of them going boom, 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 boom. You can have, two harmonics inside of there going back and forth. You can have lots of different emergent patterns in the energy going back and forth. But the key thing to understand is that it's real energy, and that I increase the energy by increasing the proximity.
Broadcasts it's sending out only travel at a set finite speed, the speed of light. To make this concrete, let's imagine taking a snapshot of our particle with its arbitrary trajectory at a specific moment in time. At this particular moment, it has a certain particular velocity, which is information not just about its speed, but also the direction of its motion, and it also has a particular acceleration. And these two things are basically the contents of the transmission.
So all it has is a position. So again, he's sort of breaking his own rule. Let's take a snapshot. In the snapshot, there is no velocity and there's no acceleration. There's just a position. And so it's going to send information from that position. It's going to reflect what the world looks like, what the world that's hitting it. It's going to reflect back to point A right now from that position. This is my reflection. If I move over here, I have a different reflection. If I move over there, I have a different reflection. And that's all that's going to change. But from one point in space, there is no acceleration. There is no velocity information from one segment of time.
It's going to broadcast at this moment. Now let's look at what happens to that broadcast after 1 second. After 1 second, this broadcast has traveled a distance of 1 light second. A light second is just a distance of how...
Right, and what he should have done for this example is to say, what is this broadcasting now at this 1 second? And draw another circle over here, pointing out that this circle is going to have energy that's behind this circle. And these two pieces of energy are going to be in sequence, a certain distance apart based on how fast this is moving. The faster it's moving, these things will end up having a period that'll be a frequency. That they'll end up sort of creating a frequency just by the amount of pressure that's hitting them. So if they're in a low pressure area, they could literally send just one bit of information now, and then this circle sends another bit, and it's a little bit behind that bit, and then it sends another bit from the third position and then the fourth position. And those bits could be equidistant apart, depending on what direction the motion is in. Now we have a frequency.
How far light travels in a second. So here is super useful. So this circle I've drawn here is showing a circle of 1 light second radius. Let's say after 2.5 seconds, the message is now here. It has just reached our point A. Now here are the 2 big points. 1. When this happens, the electromagnetic field at A will be completely dictated by this charge velocity and acceleration information that it just received. And 2, this isn't the...
It's not going to receive just information. It's going to be moved by the force. The force is going to change the pressure. It's going to have pressure coming from its backside, from its left, from its right. And presumably at the moment it's having equal pressure. But now all of a sudden there's going to be a change in the pressure, and it's going to get more density or less density because the other particle's either moving away or towards. If it's moving towards, it's going to get more density, more pressure. If it's moving away, it's going to get less density, less pressure.
Charge's velocity and acceleration right now, it's its velocity and acceleration 2.5 seconds ago. It's a time-delayed update. In fact, let's put this even more concretely. When a point A receives one of these messages from the charge, that message contains 3 pieces of information. The position of the charge when the message was sent, as well as its velocity and acceleration.
All right, so none of that is in a Planck constant of time. All of that information can't possibly exist. So you have to allow the thing to move to a few positions and then measure the density of what you're getting impacted by. So of course, when I'm moving towards you, All right, you have an increase in the density of that block of time is a higher density than that block would have been if I didn't move towards you. All right, but you have to have the block. You have to have the whole piece. If I take any one segment, I can't measure the density from one segment of time. That's not entirely true. I still have to compare it to a norm. So I still have to compare it to something outside of that one moment of time. I have to compare it to a moment 2 seconds ago to see the difference in those two moments.
At that time, there is then a rule, which we'll call the Lienert-Wiechert rule, that takes as inputs these three quantities and spits out a corresponding value for the electric field. Actually, because Lienert-Wiechert is hard to say.
Well, again, and there's no way that this thing could tell the difference between its acceleration and its velocity. So again, that acceleration requires you to take more than one moment of time and do the whole comparison. So that's certainly not going to work. The velocity argument you could almost you could make just because you could just make one static comparison. What at this exact moment is the density of the force hitting me? And it'll tell me that, well, if it's more or less than it was 1 second ago in one location. All right, well, maybe we'll stop here. This is about halfway. And do another video, or maybe not. But the point is these are pretty good videos for conventional nonsense. And it's just kind of tragic that, 1,000 views. And this channel's over a year old, 2 years old maybe. This was October 3rd, 2018. The internet's dismally broken that this stuff doesn't get found, because it's frankly, it's more like a B quality, compared to what's out there. Yeah, maybe it's not the A of the greatest of the physics learning videos, but it's definitely in the B standard. And, there's D standard crap that has 500,000 views. Anyway, so that's all I have to say about that, I suppose. So, till the next time and such.